Hey guys, welcome back to question 3 for the 2016 level 2 waves exam. Once again, it's getting quite late, so I'm gonna speed it up a little. Anna is washing her car and notices she can see drops of water on her windscreen, even though both the glass and the water drops are transparent. Why is Anna able to distinguish between the glass and the water? Simply, this is the diffraction, now I'm saying diffraction instead of refraction. Refraction, okay? Because the water and the water because the water and the glass have different refractive indices, so therefore the light bends differently in both these mediums. So you can just say water and glass are different densities. Therefore, light refracts differently. And that's all you need to say here for an achieved grade. Pretty straightforward. Next question. Anna tries to sketch a drawing of a large bead of water on her windscreen to help her understand what is happening. Use the information below to answer part B. Refractive index of air is 1. Refractive index of water is 1.33. And refractive index of glass is 1.52. And the angle of incidence at the air-water interface is 32 degrees. If the air-water interface and the water-glass interface are roughly parallel, calculate the angle of refraction in the glass as labeled. Alright, so in this case, we need to calculate the angle of refraction. So first, we need to calculate the angle of refraction of the air to water interface, and then we can only use that angle we calculated to find the angle of refraction from the water glass interface. Alright, so we're going to be using Snell's law. Okay, n1 sine theta 1 equals to n2 sine theta 2. So we start off in the air. Air's refractive index is only 1. And we have our angle of incidence. We have it as 32 degrees. So simply we can say 1 sine 32 equals 2. Water has a refractive index of 1.33. And we're trying to find the angle of refraction in the water in the water. So we just pull out a calculator here. So we've simplified this. 1 times anything is still that. So sine 32 divided by 1.33. And then we're going to do the sine of inverse of this one. So that will give us our answer. So make sure your calculator is on degrees. Very important. Or else you'll probably get a negative answer. No one likes that. We should be getting our answer as 23.48 degrees. Alright, so we find that our theta 2 equals to 23.48 degrees. So once again, we use Snell's law again, but this time with the water to glass interface to find the angle of refraction in the glass. So simply, we can just say this time the n1 is 1.33 as we're going from water to glass. Sine 23.48, and that equals 2. N2 glass is 1.52. Sine theta 2 we're trying to we'll just say sine theta 3. Sine theta 3 we're trying to find. Okay, so once again, this can be simplified. Okay, so sine 1.33 times sine 23.48 divided by 1.52, and sine inverse of the entire thing will get you yours theta 3. Okay, so 1.33 that multiplied by sine 23.48 divided by 1.52, and then we just need to calculate the sine inverse of our answer. That should give you your answer. Your theta 3 should come out as 20.4 degrees. And that should be your final answer. And getting your answer as 20.4 degrees there will get you your merit grade. To get an achieved grade, you're only finding one angle. So finding one angle there, that will get you an achieved. Alright, moving along. Anna experiments with a red laser, a Persipex bottle, and a stream of water to create a total internal reflection. State the 2 conditions necessary for total internal reflection to occur. Alright, the one condition is that the angle of incidence must be larger than the critical angle. the critical angle can occur when so angle of incidence. So when the refracted ray is 90 degrees to the normal, and when that occurs, that angle of incidence is called the critical angle. In order for the light to bend back into the medium, it has to be larger than the critical angle. Okay, and the other condition necessary is that it must be traveling from a more dense medium to a less dense medium. So from more dense to less dense is bending away from the normal, and if it's bending away from the normal, eventually the angle of refraction is going to increase so much that it's going to just simply reflect back into the medium. So we're going to say that the two conditions necessary, okay, we can just jot this down as bullet points basically. We can just say the angle of incidence must be larger than the critical angle. That's one bullet point, and then we also need to say the ray must be moving from a less dense medium to a more dense medium. I must say, from a more dense medium to a less dense medium, as it bends away from the normal. And that's actually all you need to do for this question, and that's your merit grade. Easy done. Merit grade done. And to get an achieved grade, you need any one of these. So any one of these will get you an achieved. Yeah, pretty straightforward there, actually. Complete the diagram below to show the path of the laser beam in the stream of water. On your path, on your diagram, mark the angle of incidence. The normal has been drawn for you. Alright, so obviously it wants you to show the total internal reflection, okay? So if I keep drawing, if I continue this ray, it is going to hit, it's going to hit the normal, and it's going to bend so much, okay? It's going to bend so much, it's just simply going to bend right back into the perspex, or whatever is said, glass. It's going to occur with the total internal reflection. So the ray is going to bend back into the more dense medium. So on your diagram, mark the angle of incidence. The angle of incidence is the angle that the ray makes with the normal. Don't get confused, this is not the angle of incidence, this is the angle of incidence here. Alright? Marking it correctly, just be careful. Alright. If the exact critical angle for red light is 48.7 degrees, calculate the refractive index of water for red light to 3 decimal places. Once again, this is simply just Snell's law, okay? N1 sine theta 1 equals to N2 sine theta 2. The exact critical angle for red light is 48.7 degrees. So it's saying that when the angle of incidence is 48.7 degrees, the ray is going to refract at 90 degrees to the normal. So basically, when the angle of incidence is 48.7 degrees, angle of refraction is 90 degrees. And it says to calculate the refractive index of water, and mark it to 3 decimal places. We know that the refractive index of air is 1, okay? So therefore we can say we know that it's traveling from the more dense medium to the less dense medium. So therefore it must be traveling into the air, okay? So we're going to say that N1 we don't know because it's traveling from a more dense medium. We're trying to find that refractive index. Sine of 48.7, that's the angle of incidence. That equals to N2, we know it's 1. 1 sine 90. Because it's sine 90 because the angle of refraction is 90. Sine 90 is 1, okay, so N1 sine 48.7 equals to 1. N1 equals to 1 divided by sine 48.7. 1 divided by sine 48.7. That gives you your answer as N1 equals to 1.331. So once again, pretty straightforward, and actually these two questions combined, that will get you your excellence grade, okay? So that's the diagram correct and answer correct. Excellence. to get a merit grade, okay, you need to have the correct path of the laser beam, and correctly. So the diagram needs to be correct. So basically, it's everything correct by one error. One error will get you your merit grade, and to get an achieved grade, okay, you need to draw you can either draw the correct diagram or correct calculation. So either one of these will get you an achieved. All right, next question. Oh, that's it actually. Alright, so thank you for watching this video on level 2, these past 3 videos on level 2 2016 waves. If you enjoy these videos, please leave a like below, and please leave a comment down if you have any more feedback on the videos. And thank you for watching this episode. Thank you, and I'll see you in the next one. Thank you. Bye.